Okay, this is our tutorial for section 4.2, strategies in proving identities. And there are some helpful tips in your textbook on, they kind of go through 7 different steps that you take. And the first step that you always look for is just simplifying the heavier side or the complicated side. And I've got an example of that here. And you always want to look at simplifying by multiplying or collecting terms, or making it or expanding it or something like that. So here we'll just multiply these together. So this is equal to secant squared theta. Okay, minus secant theta plus secant theta minus 1. Okay, that's the left side. So these cancel out. So we've got secant squared theta minus 1. And if we look at our identities, our 8 identities again, we have a Pythagorean identity there. And again, I'm just flipping back here. It's on page 139. And we know that secant squared minus 1 is equal to tan squared theta. So you just have to rearrange that identity. They have it 1 plus tan squared theta equals secant squared. So you just bring the 1 over here. So this is equal to tan squared theta, which proves both sides. And the reasoning here would be that's an identity, and here you just expand it. Okay, there are some more complicated ones here that I have. You just check to make sure that's in our field of view. Okay, I have a couple here. I've selected a couple of these out of the book. I tend not to do that when I'm trying to do my tutorials. I try to make my own up, and so that you can use the book examples for yourself. But I just chose some out of the exercises, as sometimes it's difficult to come up with provable questions quickly. So I just kind of picked a few that we can do. So the next tip that they often give is to change the form of one side into the other, and then kind of you look at it, well, there's secant on both sides in this one, but there's a tangent in there. So we've got to kind of think in terms of how we want to change that one around. So one of the things you can do here is you can look at and say to yourself, what form can I put this here in? Well, that's the same as saying secant squared minus 1. Oh, theta, I forgot the theta there. Minus 1 times, I'm factoring this, which is another tip in the proving identities. Sometimes you need to factor things out, and this would be secant squared plus 1 theta. Keep forgetting to put the theta in there. And I'm working with the left side, and that's over tan squared theta. Okay, so 1's plus and 1's minus because there's no middle term in there. If we know that, we can see to ourselves that if we look at the Pythagorean identity here on, again, page 139, and we want to look at secant squared again, so I'm just going to flip back to page 139 and look at the form there. It says that secant squared is actually equal to, tan squared would be equal to, because we want to eliminate this here tan squared on the bottom, so we want to change these one of these into tan squared. So tan squared would be equal to secant squared theta minus 1. So we can then say this one would be tan squared theta, still times this here, right, over tan squared theta. So these would drop out. And then that would show you that secant squared theta is left, plus 1 is left here on the left side, which is the same as the right side. Okay, so What we did in that case was we used one of the tips, and one of the tips is to factor, and then to simplify, and then use an identity, and then to simplify. Okay, I've got a third example here that we should be able to finish. Let me just make sure we have enough time. Yep, I think we can do it. What if you had something like this? Well, another tip that they give you for these types of questions is converting your, if you got a lot of different kinds of things in here, and it's kind of complex on both sides in this case, and one of the better things to do is to convert the form of, well, let me see here if I got the right one here. Yep, there it is. Convert the form that you have and actually convert it into a form where you can actually change it into, see, I've already done that one on this one. I did a step extra here. This is supposed to be tan theta here, plus this stuff. Convert it into the forms of sine and cosine. So I already did the first step accidentally here when I wrote it down. That's where it confused me a little bit. My question should have been tan theta plus 1 over cos theta equals 1 over cos theta over that stuff. So then what we did, my first step would be to change the tan into the sine and cosine, and then to simplify using a common denominator here between what we have on our whole question here. So what we can do then is we can say to ourselves, well, this is pretty simple. Take the common denominator, sine. This would be sine theta times sine theta, because we want the common denominator to be cos theta sine theta, right? And we had cos theta, so we have to multiply sine theta there, plus 1 plus cos theta. Okay? And what's the common denominator? It had sine already on the bottom, so we need to multiply that by cos theta. So if I continue on, this is sine squared theta plus cos theta plus cos squared theta, all over this stuff here. Okay, so what I have then when I work it out is that we can combine these two into a Pythagorean identity. So this would be equal to cosine, let's cosine theta. And then we'd have plus sine squared theta plus cos squared theta. Still working with the left side all over this. I'm just grouping so that now we can use the Pythagorean identity for sine squared cos squared theta. That's equal to 1. So then it becomes cos squared theta plus 1 all over cos theta sine theta. And that's what the left side is, and that's what the right side is. So we've then proved that one. Okay, I've got one more here, but I don't think I have enough time to complete it. It's a little bit longer one. And that's completing more complex examples like this, where you just got to start by going right into it and converting everything into sine and cosine, and then trying to make it equal to this side here. So I'll do that in the next tutorial.